Let's do part A. So here we have to determine cosine of the theta, where theta is the angle between the two given vectors v vector and w vector. So for this, we are going to use the dot product of two vectors formula. That is, if we have two vectors, a vector and b vector, and the dot product is given by a dot b, this is given by magnitude of a vector times magnitude of b vector times cosine of the theta. That is, theta is the angle between the two vectors. So from this, we can determine cosine theta by dividing both sides by magnitude of A times magnitude of B. So cosine of theta gives A dot B. This is the dot product between the two vectors divided by the magnitude of A vector times the magnitude of B vector. So we will utilize this formula to determine the cosine of the theta between those the two vectors v vector and w vector. So when we use this formula, we can substitute that we have two vectors v vector and w vector. So in the numerator, we have to find the dot product by writing v dot w and then dividing by the magnitude of two vectors. Magnitude of v vector, we write down this as magnitude of v vector and magnitude of w vector. So let's evaluate this. We know from the dot product v dot w, we have to multiply the corresponding components and add them together. So I can write down this v dot v. I take this 1 from v vector and 9 from the w vector, multiply them. So it becomes 1 times 9 and add with the other component, that is 6 with 7. This is the component for the j vector, the unit vector j vector. 6 times 7 plus the other component is the 9 times 5. So this is basically the dot product of two vectors v vector and w vector divided by the magnitude of v vector. To find the magnitude of v vector, we square the corresponding components, add them together, and then take the square root. So I put the square root. Sum of the squares of the corresponding components, that is 1 squared plus 6 squared plus 9 square. This is the magnitude of v vector, and then the magnitude of w vector is take the square root and sum of the squares of the component, that is 9 squared plus 7 squared plus 5 square. So let's evaluate this expression. The numerator, we have 1 times 9 is 9 plus 6 times 7 is 42. 9 times 5 is 45 divided by the first square root. It is 1 squared is 1, 6 squared is 36 plus 9 squared is 81. This is under the root. And the second expression is 9 squared is 81 plus 7 squared is 49 plus 5 square is 24. I'm sorry, it is 25. So this gives 9 plus 42 is 51. So we have 45 plus 51. This is 96. So write 96 under the root divided by 36 plus 1 is 37 plus 81. So this is 118 under the root of 118. And here we have 81 plus 49. This is equivalent to 81 plus 49, 12, and 130 plus 25, and this gives 155. So this is 155. We can plug this into the calculator, and when we do this, we approximately get 0.70985, and this is in 5 significant figures. Therefore, cos theta is approximately 0.70985. Let's do part B. So here we find the projection of W along V, and this is given by the formula W dot V divided by the magnitude of V square times the V vector. So let's determine this. Since we have already calculated V dot W, we know from the dot product rule, the dot product is commutative. That is, V dot V equals W dot V. So we have already calculated v dot v from the part 1, that is from part A, which we can utilize it here. So this is the numerator expression is the v dot w. So when we simplified, we obtained 96. So I'm going to plug in 96 for w dot v, and then magnitude of v square. So this is the magnitude of v. This expression is the magnitude of v, and we have to take its square root. So when we simplified, we obtain under the root 118. So this is the magnitude of v. I'm going to utilize this, and we have to take this square. So we put magnitude of v is 118 under the root, and this has to be square times the v vector. Let's utilize the v vector. It is 1 comma 6 comma 9. So I'm going to put 1 comma 6 comma 9 for v vector. So let's simplify this. So this gives 96 divided by 118 times 1 comma 6 comma 9. And we can distribute this into the terms inside the brackets. So we will have 96 by 118 comma 96 times of 6 divided by 118 comma 96 times 9 divided by 180. And so this gives, when we plug this into the calculator, we approximately get 0.81356. And this is written in 5 significant figures. And the next term is 4.8814, 5 significant figures. And finally 7.3320. So this is also written in 5 significant figures. So this is the projection of W along V.